All right, this review is a Cal 1 review with 2.5 and 2.6. So we're doing 3, 5, 6, 8, 9, 10, 11, and 12 from 2.5, 1, 2, 3, 7, 8, 9, and 10 from 2.6. I'm going to go fairly quickly since I don't have to ask if you understand, but I will be explaining as I go along and I will be talking as I go through them. So first 2.5, number 3. Go ahead and cut everything. All right. We're talking about implicit differentiation here. So we're going to treat this like it's a function to the 8th power. So we bring the 8 out front, rewrite it, cosine pi x plus sine pi y to the 7th power. Remember, keep that the same, decrease by 1. Now, chain rule tells us to take the derivative of what's in here. So the derivative of cosine is negative 7, or negative sine pi x times the derivative of the argument, which would be times pi, plus the derivative of sine pi y, which would be cosine pi y, times the derivative of pi y, which would be pi dy dx. Remember, y is a function of x, so when we take the derivative of y, it's dy dx. And all of this, close those parentheses, equal to the derivative of 60, which is just 0. So in this problem, you'll notice that only one, you've got this is a factor, this is a factor, and this is a factor, but only one of them has the dy dx in it. So that's the only one I can use to solve. So the principle of zero products tells us that one of these things has to be equal to 0 for this to be equal to 0. So we're going to set this up, negative sine pi x, well, we'll write it as negative pi, right, bring the pi out front, sine pi x, plus pi cosine pi y dy dx equals 0. I'm going to bring that sine over. I'm going to add that to both sides. So pi cosine pi y dy dx equals, added that over, becomes positive sine pi x. And since I want dy dx, I'm going to divide by pi cosine pi y. Pi cosine pi y. So I get dy dx equals, the pi's cancel out, and I have sine pi x over cosine pi y. Now remember, these are arguments. You can't cancel those pi's out because these are not things that are being multiplied together. And because the arguments are different, I can't turn that into tangent or anything. That is just my final answer. Number 5. All of these 2.5 ones are implicit differentiation. And this one's actually a little bit easier in my opinion. Y equals sine xy, so we're finding dy dx. So we take the derivative of both sides. So the derivative of y is dy dx. The derivative of sine is cosine xy. And then we have to take the derivative of xy. Now that is a product. First times the derivative of the second plus second times the derivative of the first. All right, so in this case, we need to go ahead and distribute. So we're going to have dy dx equals x cosine xy dy dx plus cosine xy. All right, now, since we're trying to get the dy dx's together, we need to make sure and subtract over that x cosine xy. So minus x cosine xy, dy dx to both sides. So we'll have dy dx minus x cosine xy dy dx equals cosine x y. Now we're going to factor the dy dx out because it's a common factor. Once you've got everything with a dy dx on that side, you can factor it out. Leaves us with 1 minus x cosine xy equals cosine xy. And then we divide by the 1 minus x cosine xy, and we get dy dx equals cosine xy over 1 minus x cosine xy. That's number 5. Oh, what did I miss? Looking at this, I just realized I had that y, not just a 1. So when I distribute that cosine, that should be y cosine xy. That should be y cosine xy, and there should be a y cosine xy there. Be careful. Make sure you don't lose anything when you do that distribution. All right, so the next one is 6. Another implicit differentiation. This time we've got x equals the secant of 1 over y. So I'm going to start by rewriting this as x equals secant of y to the negative 1. And I do that because when I take this, I'm going to need to take the derivative of that argument, and it's easier to do it that way. We're going to have, let's see, secant of 1 over y. So the derivative of secant is, well, first off, the derivative of x is 1. The derivative of secant is secant tangent. So it would be secant 1 over y tangent 1 over y. And then times the derivative of y to the negative 1, which would be negative y decreased by 1, so negative 2. All right, so we wind up with negative 1 over y squared secant 1 over y tangent 1 over y equals 1. Oh, scratch that. When I did that, I also have got a dy dx, right? All right, so now I need to divide by everything to get the dy, because all these things are being multiplied together, right? So I need to divide by everything. So if I divide by secant 1 over y, tangent 1 over y, and negative y to the negative 2, that will equal dy dx. So looking at that, I can tell I can just bring the y to the top. So I'm going to have negative y squared. The reciprocal of secant is cosine, and the reciprocal of tangent is cotangent. So that will be our final answer. I like that problem. And then we've got number 8. So find dy dx by implicit differentiation. Now, for a problem like this, the first thing we want to recognize is that there's common factor in here. That 4, we can rewrite that as 4 times x plus y cubed equals 64x cubed plus 64y cubed, right? Now notice that 4 cubed is 64, so this is 64x plus y cubed, right? I cubed the 4 and I cubed the x plus y. Equals 64x cubed plus 64y cubed. Well, looky there. That 64 will actually factor out over here, and I can cancel all that out. And I've just got x plus y cubed equals x cubed plus y cubed. So we're going to differentiate both sides. So 3 times x plus y squared times the derivative of x plus y, which is 1 plus dy dx, right? Derivative of x is 1, derivative of y is dy dx, equals 3x squared plus 3y squared. Remember to tack on the dy dx because that's a function of x. So we need to distribute here. So we're going to get 3 times x plus y squared times 1 plus 3 times x plus y squared dy dx. Right? I just distribute the whole thing through. Equals 3x squared plus 3y squared dy dx. So I need to combine my dy dx's. So I'm going to bring this one over here, but I'm going to take this one over there. So I'm going to wind up with 3 times x plus y squared dy dx minus 3y squared dy dx equals 3x squared minus 3 times x plus y squared. Now, once again, I've got that dy dx in common, so I can go ahead and factor that out. So dy dx, and it's going to leave me with 3 times x plus y squared minus 3y squared equals, same thing over here, 3x squared minus 3 times x plus y squared. All right, now, I don't know if you noticed this or not, but there's a 3 in all of those. So I can factor the 3's out and actually cancel them. So I wind up with dy dx times x plus y squared, which is x squared plus 2xy plus y squared, and then minus y squared, equals x squared minus, and then I'm going to factor that, x squared plus 2xy plus y squared. So, notice those y squareds cancel out. I've got dy dx times x squared plus 2xy equals, over here, if I distribute that through, the x squared minus x squared will cancel out. So I've got negative 2xy, and I've got negative y squared. Then I can divide by the x squared plus 2xy. Gets rid of that, so dy dx equals that. Number 9. Number 9 says to find the slope of the tangent line at a given point. Well, that just means take the derivative and plug in x and y, right, and solve for dy dx. So remember, dy dx is what we're looking for. So we've got a product rule. So first times the derivative of the second, which is 2y dy dx, plus the second times the derivative of the first. So the derivative of negative x is negative 1, equals 3x squared. All right, so we're going to, this is negative y squared, so we're going to add that over there. So 10 minus x times 2y dy dx equals 3x squared plus y squared. So we can divide by 10 minus x times 2y. 10 minus x times 2y. I get dy over dx equals 3x squared plus y squared over 10 minus x times 2y. So we're going to plug our xy in. So x squared is 2 squared, which is 4, times 3 is 12, plus y squared, which is 1. On the bottom, I'm going to have 10 minus x, so that's 10 minus 2, which is 8, times 2 times 1, so times 2. So we get 13 over 16. And that's our final answer. Number 10, find an equation of a tangent line. So we've done this multiple times. This is one of my favorite types of questions. So we're given this. So we need to find the tangent line. So I know I can find the derivative of the tangent line, or the slope of the tangent line, which is the derivative. So if I take the derivative, 2 times y minus 3 to the first, and then times the derivative of y minus 3, which is dy dx, equals 4. Right, because the derivative of 4 times x minus 5 is just the derivative of 4x minus 20, and that's just 4. So this is dy dx equals 4 divided by the 2 times y minus 3. And then I'm going to plug in my y value, which is negative 1, which is 4 over 2 times negative 1 minus 3 is negative 4. So we wind up with 4 over negative 8, or negative 1/2. So that gives me my m, right? So y minus y sub 1 equals m times x minus x sub 1. This is m, this is x sub 1 and y sub 1. Or this is x, y, and m, and I can use y equals mx plus b. So if you know this formula, we'll say y minus negative 1 is plus 1 equals negative 1/2 times x minus 9. So y plus 1 equals negative 1/2 x plus 9/2, right? Because negative 1/2 times negative 9 is plus 9/2. So we're going to subtract 1. So we get y equals negative 1/2 x. 9/2 minus 2/2 would be plus 7/2. Same thing over here. We could do y equals m times x plus b. So negative 1 equals negative 9/2 plus b. Add 9/2 to both sides. We get 7/2 equals b. So y equals m, which is negative 1/2 x plus b, which is 7/2. Either way you do it, you get the same answer. Number 11. Use implicit differentiation to find an equation of the tangent line. Same exact problem, just a different type of implicit differentiation. Start by finding the slope, and then use point slope form or y equals mx plus b. So we've got, I'm going to rewrite this as 1/10 x squared plus 1/6 y squared equals 4. So I get 2 times 1/10 or 1/5 x plus 2 times 1/6 or 1/3 y dy dx equals 0. So we're going to move the x term over, make that negative 1/5 x, and then we're going to multiply by 3 over y. That way the 3's cancel out and the y's cancel out. So we wind up with dy dx, that looks like dx, doesn't it? Equals negative 3x over 5y. And we've got our x and our y up here, so this is just negative 3 times 5, or 5 times 3, negative 15 over 15, or negative 1. All right, so that gives me my slope, and then of course I can go back in. If this is my x and my y, and m equals negative 1, then y equals mx plus b means 3 equals negative 1 times 5 plus b. So 3 equals negative 5 plus b. Add 5, b equals 8. Therefore, my equation y equals mx plus b. And then lastly, number 12. Which asks us to find equations for the tangent line and the normal line. So what's really important here is to recognize that normal lines are just the lines that are perpendicular to the tangent line. So it's going through the same point, but it has the opposite reciprocal slope. Remember, perpendicular lines have the same slopes, only one is the opposite sign and the reciprocal, right? So I say they've got the same. They've got the same numbers. They're just flipped and then negated. So the negative reciprocal. So we're going to start by finding the tangent line. So we take the derivative, 2x plus 2y dy dx equals 0. Move the x term over and divide by 2y. We get dy dx equals negative x over y. So at the point 3, 4, then dy dx equals negative 3/4. Okay? Now, when we find the tangent line, we're going to use the m equals negative 3/4. We're going to use this point, so y equals mx plus b, or 4 equals negative 3/4 times 3 plus b. That's negative 9/4 plus b. So we're going to add 9/4. Right, so we're going to get, that's going to be 16/4. So 25/4 equals b. Therefore, y equals mx plus b. Now, the normal line, the m will be the opposite sign, so it'll be positive, and instead of 3/4, we switch it, and it's 4/3. And we still use the same point. So we get 4 equals 4/3 times 3 plus b. You get 4 equals 4 plus b. Subtract 4, b equals 0. Therefore, y equals mx plus b. You have no plus b because the b is 0. And then when we graph them, x squared plus y squared is always a circle. One, two, three, four, five. So since this is x squared plus y squared equals 25, that means the circle goes out to 5. All right, and then we have y equals 4/3 x. So that would go through the origin up to 1, 2, 3, 4, 1, 2, 3, 4, 5, something like that. And then the normal line is negative 3/4 25 over 4. Now remember, we're going through the point 3, 4. So 1, 2, 3, 1, 2, 3, 4. It's somewhere in here. The tangent line should look like that because it's only touching in one spot. So when you look at these pictures, you're looking for one that has the right circle, where the intersection is on the circle, and where the two lines are, one of them is touching and one of them is going through. So if we look at our different options on this one, this one, neither one of these lines is tangent. This one, neither one of the lines is tangent. This one, the line is tangent here, but remember, they have to be going through the same point. So this one doesn't go through that point, right? This one, notice what happens. It's tangent, and the normal line goes through it. So it's got to be that one. All right, so that's all the problems for 2.5. Now we're going to jump into 2.6. And we're going to do 1 through 3 and 7 through 10. Let me get my snip tool. And when these have multiple parts, I'm only going to do the first part because the second part would be exactly the same. Like for this one, assume that x and y, well, hold on. No, I'm going to do both parts. I'm going to do both parts. Just to make sure you understand. So, we've got y equals square root of x. So we're going to rewrite that as y equals x to the 1/2. So when we differentiate it, we get dy dx equals, and we're not doing, be careful, make sure you read it. They're both functions of t. Right? Both of them are functions of t. So no longer are we saying that the derivative of x is just 1. Now the derivative of x is dx dt, because we're talking about it being a function of some other variable. So, the derivative of y is dy dt. Remember, this is y equals x to the 1/2. And the derivative of x is 1/2 x to the negative 1/2 dx dt. Both of them have to have that differential on them now, considering they're both functions of some other variable. So, this tells us to find dy dt given that x equals 9 and dx dt equals 5. So we can rewrite this as 1 over 2 x to the 1/2 and then dx dt, which is 1 over 2 square root of x times dx dt. So if x is 9, this is 1 over 2 square root of 9, and dx dt is 5, then this gives us 1 over 2 times square root of 9 is 2 times 3, which is 6, times 5, which is 5/6. And then part B has us do the same thing, only it wants us to find dx dt if we're given these other values. So So using the same equation, which was dy dt equals 1 over 2 square roots of x dx dt, plug in x equals 64 and dy dt equals 8. So dy dt equals 8, 1 over 2 times the square root of 64 dx dt. So 8 equals 1 over 2 times 8 dx dt. So 8 equals 1 over 16 dx dt. So I've got to multiply both sides by 16. And I get dx dt equals 16 times 8, 48, 128. Number 2, same exact kind of problem, just a different implicit differentiation. So xy equals 6, we've got to do 1d2 plus 2d1, right? So first times the derivative of the first plus second, or first times the derivative of the second plus second times the derivative of the first, derivative of 6 is equal. So when I do this, y prime means dy dt, x prime means dx dt. So this one says to find dy dt given that x equals 6 and dx dt equals 14. All right, so here's one issue that some people have. That gave us the x, so we can do 6 y prime plus y, x prime is dx dt, so that's 14 equals 0. But now I've got a y prime and a y. So how do I solve for y prime if I don't know what y is? Well, guess what? X equals 6, so 6y equals 6, right? You can just plug that in and solve for y. So y equals 1. So 6y prime plus 1 times 14 equals 0. Move the 14 over and divide by the 6. Y prime equals negative 7/3. And then we'll do part B. All right, so find dx dt. So we've got x y prime plus y x prime equals 0. So if x equals 1 and y prime is negative 8, what is y? So if x is equal to 1, then 1 times y equals 6. Divide by 1, y equals 6. So this is 6 times x prime equals 0. So negative 8 plus 6x prime equals 0. Move the 8 over. 6x prime equals 8. Divide by 6. X prime is 4/3. And then number 3. Once again, these are all the exact same kind of problem, just different implicit differentiations. But we've already implicitly differentiated one like this. It's this circle. So the only difference here is now x is also a function of t. So x squared is 2x dx dt. And then the derivative of y squared is 2y dy dt equals 0. So notice I can divide the 2 out. Right, if I divide this by 2, divide this by 2, and divide this by 2, I get x dx dt plus y dy dt equals 0. Now, it wants us to find dy dt given that x equals 5, y equals 12, and dx dt equals 8. This is actually even easier because they give us x and y. So if x is 5, x prime is 8, y is 12, y prime equals 0. 8 times 5 is 40 plus 12y prime. Move the 40 over and divide by 12. You get y prime equals, let's see, both of these are divisible by 4 for sure. 3 and 10, yeah, so negative 10/3. And then the second part, B, asks us to find dx dt if we're given different values. So we still have x prime plus y prime equals 0. So if x is 12, I don't know what x prime is, that's what I'm solving for, plus y times y prime, or dy dt, equals 0. So 12x prime minus 20 equals 0. So add the 20 to both sides and divide by 12. X prime equals, so these are both divisible by 4, so 5/3. All right, now down to 7. Copy. This is our trough problem. All right, it says, for part A, if water is being pumped in at 2 cubic feet per minute, how fast is the water level rising when h is 1.6 feet? So this height is what's changing. So I'm looking for the change in height, or dh dt. Remember, dh means change in, so we're talking about the change in height over time. This 2 cubic feet per minute is nothing more than the change in volume. So dv dt is equal to 2. So we've got two things. And we need some way to relate v and h. But what I want you to notice is this water here is in the shape of this triangular prism, right? So the area, or the volume, I should say, of a triangular prism is just the area of the triangle times the length of the prism. So the volume would be 1/2 base times height, because that's the area of the triangle, and then times its length. So in this case, that would be times 12. So the volume of this one would be 6 times the base times the height. Now, problem is, we've got that base in there, and we're like, well, I don't know how to, right? This is two different variables, because the base will be changing, right? This is our base, and then this is our height. But I want you to look. In the big triangle, the base and the height are the same, which means that every triangle inside of that will also have the same base and height. The base and the height will be the same because they all have the same angles, and we know that any triangle that has all of the same angles, all of the ratios will hold inside of it, like the length of the height to the base, or the length of side A to side C. All these variables will always, these ratios will stay the same. So since the ratio of the base to the height is 1, then that will be the same no matter where we're at. So we're going to say that B is equal to H. Therefore, our volume now is equal to 6H squared. And now we can solve this by differentiating and get dV dt equals 12H dH dt, right? We're treating H as a variable, which is a function of time. And it tells us that H is 1.6 feet, and we know what dV dt is, and we want to find out how fast the water level is rising. We're looking for dH dt. So we plug all that in. dV dt is 2, H is 1.6, dH dt. So we're going to multiply 12 times 1.6. We're going to get 96/5, which I don't like. 19.2 dH dt equals 2. So 2 divided by 19.2, it's going to give us dH dt equals, what is that, 5/48. All right. Now part B says that if the water is rising at a rate of 3/8 inch per minute when H equals 2.2, determine the rate at which the water is being pumped into the trough. So no longer is that dV dt equal to 2. We can erase that part. But I am given that the water is rising at a rate of 3/8 inch per minute, so dH dt is 3/8. I'm going to come back to my formula, dv dt, which is now what I'm looking for, equals 12 times h, which is 2.2, times dh dt, which is 3/8. So 12 times 2.2 times 3/8 equals 99/10. No, hold on. 12 times 2.2 times 3/8. Hold on, something's. Have y'all found my mistake yet? Oh, yeah. What's the problem? All this is in feet, right? So this is 3/8 is an inch, right? This 5/48 that we found a while ago was feet per minute. Since this is inches per minute, I need to change, since this is inch, we need to say that there are 12 inches in 1 foot so that I can cancel the inches out and be into feet. So I'm going to have to multiply that by 12, or divide that by 12, and I get 33/40, and now this would be feet cubed per minute, right? Because it's changing volume. Minute. So be aware that those you've got to watch those signs or those units and make sure that you're in the proper unit. I have a tendency to forget about that. All right, number 8. It's a long one. And I'm only going to do one of these. This has got multiple lengths. I'm going to change this, and you'll see why in just a second. So I'm going to change this to 20, which is one of the ones we have to do. So if you can do 20, you can do anything. So we're given this ladder, which forms a triangle, right? We have the x, we have the y, and we have this is 25. Now, if I'm moving this in this direction, my x will be changing and my y will be changing. So my change here is dx dt. My change here is dy dt. Okay? Now, is there some relationship that I can relate x and y together? Well, I know that x squared plus y squared equals 25 squared, right? So if I differentiate this, I get 2x dx dt plus 2y dy dt equals 0. So this gives me x dx dt equals negative y dy dt. Notice I moved one of them over and I canceled the 2's out. So it's asking, what is the velocity of the top of the ladder? So that's dy dt, right, coming down, when the base is 20 feet from the wall. So when x equals 20, I know dx dt is 2, right? It's given. I'm looking for dy dt. I just need y. Well, if I know x equals 20, I can plug it in up here and figure out what y is. So 20 squared plus y squared equals 25 squared. So 625 minus 400 equals y squared. So y squared equals 225, or y equals, I think that's 15, isn't it? Yeah. So y equals 15. So y equals 15. So I can plug all this in. X times dx dt equals negative y times dy dt. So 2 times 20 is 40. I'm going to divide by the negative 15 equals dy dt. So 40 over 15, they're both divisible by 5. They're both divisible by 5. So 8 thirds, so negative 8 thirds feet per second. Part B says, consider the triangle formed by the side of the house, the ladder, and the ground. Find the rate at which the area of the triangle is changing when the base of the ladder is 20 feet from the wall. So 20 feet from the wall, I still have all of this values are the same, dy, dx, x, and y. But now I want to talk about the area. So I know the area is equal to 1/2 the base times the height, right? So I can talk about my change in area as the derivative of a with respect to t. So that gives me 1/2, and then dx dt times y. Well, let's do it. Let's do it first, derivative of the second. X dy dt plus the second times the derivative of the first. And I have to literally just plug these values in. So x was 20, dy dt was negative 8 thirds, plus y, which was 15, times dx dt, which was 2. So if I plug all that in, 1/2 times 20 times negative 8 thirds plus 15 times 2, negative 35 thirds, right? So that means that the area is going down, right? And then part C wants us to find the rate at which the angle between the ladder and the wall is changing. So we're talking about this angle right here. So once again, I've got x and y. Do I have some relationship between x and y and theta? Guess what I do? Tan theta equals opposite over adjacent. So if I do this, the derivative of tangent is secant squared theta and then d theta dt, right? Because theta is a function of time, equals low d high minus high d low over low low. So over here, to get rid of the secant squared, I'm going to divide by secant squared, which is the same thing as having cosine squared on the top, right? So we can change that to cosine squared theta on the top. Remember, secant squared theta is just 1 over cosine squared theta, right? So they're reciprocal of each other. So over here, I know my values of x and y. So x was 20, y was 7. That means this is 25, right? So cosine theta is adjacent over hypotenuse, 7 over 25. So I can now plug in every one of my values. So y was 7, dx dt was 2, minus x, which is 20, times dy dt, which was negative 8 thirds, and all of that times 7/25 squared, right? Cosine theta squared, over y squared. Y was 7, so 7 squared. So I get 14 minus or plus 160 over 3 times 49 divided by 25 squared, all divided by 49. Let me make sure I plug this into my calculator right. Parentheses 7 times 2 minus 20 times negative 8 thirds times 7 over 25 squared divided by 7 squared opposite over adjacent. This is giving me a weird number. opposite over adjacent, low d high minus high d low over low low. Y was 7, dx dt was 2, minus x, which is 20, times dy dt, which was negative 8/3, cosine squared so cosine is adjacent over hypotenuse. Let's see. Oh, I see. Why have I got y equals 7? I know all of y'all are out there going like, no, y was 15. So that's 15 over 25, which is actually 3/5, right? So instead of 7 over 25, I'll have 3/5. Instead of 7 squared down here, I'll have 15 squared. I think this will be a little bit better. 14 minus 20 times negative 8/3 times 9 25ths, and then divided by 15 squared. Now, hold on. I've got a 7 in there still. That is supposed to be 15. So 15 times 2 is 30, minus 20 times negative 8/3 times 9 over 25 divided by 15 squared gives me 2/15. Right? That's better. All right, number 9, very similar to that one. It'll be using a Pythagorean identity as well. And then you've got this little picture here. And I love that it says not drawn to scale. All right, so airplane flying at an altitude of 6 miles. So we've got 6. So now we've got a triangle where this is given, and then we have x and s. So we know that 36 plus x squared equals s squared. So 2x dx dt equals 2s ds dt. Cancel the 2's out. X dx dt equals s ds dt. It says when the airplane is 10 miles away, so when s equals 10, so if s equals 10, then I know that 6 squared plus x squared equals s squared. So x squared equals 64. X equals 8. So when the airplane is 10 miles away, the radar detects that the distance s is changing at a rate of 260 miles per hour. So it tells us that ds is 260. What's the speed of the airplane? Well, notice the airplane is going in this direction. That's the change in x. So we're looking for dx dt. So x dx dt equals s, which was 10, ds dt, which was 260. So we're going to divide by 8. dx dt equals 260 times 10 divided by 8. 260 times 10 divided by 8. 325 miles per hour. And then lastly, we've got number 10. Which is some chemistry. We get so used to doing physics, it's nice to have a chemistry problem. All right, we're given when a certain polyatomic gas undergoes adiabatic expansion, its pressure P and volume V satisfy the equation PV to the 1.6 equals K, where K is some constant. Find the relationship between the related rates dP dt and dV dt. So this is all about taking a derivative, right? So what we're going to do is we're going to say, all right, if, and this is not P, this is rho, pressure rho. It should have like a little curl on it. No, I think this is actually P. I think this may actually be pressure. Well, actually, we'll talk about it as a P instead of a rho. So P V to the 1.6 equals K. So we're going to take the derivative, and the problem tells us to find dv dt. So we're going to take this. This is a first times the derivative of the second. So first times the derivative of the second, which is 1.6v minus 1, so to the 0.6, plus, or times dv dt, right? Plus the second times the derivative of the second. And then the derivative of k, they said that's a constant, so that's just going to be equal to 0. So we're going to keep this over here, so we're going to move the other over, so we get p 1.6v to the 0.6 dv dt equals negative v to the 1.6 dp dt. And then we're going to divide by p, and I keep putting that 1.6 in the middle. Let's put the 1.6 out front. P v to the 0.6, 1.6 p v to the 0.6. So if we've got v to the 1.6 on the bottom and v to the 0.6 on the bottom, remember we subtract, so that just gives me negative v on the top. I've got 1.6 p on the bottom, and then the dp dt. And that is their relationship.